Hey guys, so we are starting day 2 of lesson 6.5. Yesterday we talked about 3 situations in which you can arrange molecules in an atom, atoms in a molecule, and without the presence of any lone pair. So we talked about linear, which is like this. There you go. See, it's a flat line and they're 180 degrees away from each other. We also talked about trigonal planar, where they're shaped like a triangle, 120 degrees away from each other, and they're planar, which means that they are not technically 3D. They are all on the same plane. All right. And then we also talked about tetrahedral. Tetrahedral is going to be very important to our discussion today. Tetrahedral geometry is like this guy, right? You can see right here that as you move them closer to each other, they repel each other and everything goes back to being 109.5 degrees. And in the end of the day, you can see that some of them point into the screen, some of them point out, and they are taking on this conformation because this is the furthest away that they can be. If they were all facing in a 2D model, they would only be 90 degrees away, which would end up not being a huge advantage for them. All right, so today what we're going to do is we're going to be introducing lone pairs into our models, okay? Obviously, we're not going to have to draw any of these, but that's just the case. So you guys remember, a lone pair is a pair of electrons which does not participate in bonding. So you guys remember when we learned about Lewis structure, that every structure wants to have 8 electrons on its outside for it to be happy. So you know that water has 6 valence electrons. Oxygen has 6 valence electrons with 1 here and 1 here. So each one of these binds to a hydrogen in order to form 8 valence electrons overall, and each hydrogen has 2 because they only have the first energy level, right? So this is basically what we're always trying to achieve. We always want to have 8 valence electrons overall, but sometimes those valence electrons are not participating in a bond, and those are called lone pairs. So you can see here that the oxygen has 2 lone pairs and the nitrogen has 1 lone pair. All right? So these are extremely important because they also add to the geometry of the molecule. So they also take part in forming the 3D structure of a molecule. All right? So if I look over here, this is ammonia. Ammonia has a formula of NH3. So if I was really going to think about this, I would say that this is AB3, which means that it should be trigonal planar, right? Like this, H, H, H. But this does not take into account of the fact that ammonia or nitrogen has 1 lone pair right here. And a lone pair actually counts as part of the molecule, and it actually takes an equal part when it comes to forming the molecular structure. So we have to basically say that this is just another part. So in reality, instead of saying AB3, this molecule would actually behave more like AB4, which means it would behave more like tetrahedral because there are 4 components, the lone pair and the 3 hydrogens. So if I go ahead and I look over here and I go to an ammonia atom, let's say here NH3, I will see that it is not a flat triangle. It's basically a triangle and everything is pointing downwards, right? And this is because of this lone pair up here, okay? We'll get into this a little, the bond angle a little bit later, but basically this lone pair takes its part in the atom. Just like any of these, the lone pair also has a specific position that it has to take. Now you guys can probably see the bond angle here is 107.8. Very close to 109.5. We'll talk about why this is not exactly 109.5 by the end of this lesson. But for now, you just need to understand that this is not going to be planar because there's a lone pair pushing all of them downwards and away from the lone pair. Because remember, lone pairs repel against the atoms, and the atoms are also repelling against each other to form this 3D structure. All right, so you guys can see here, this one is called trigonal pyramidal. This is because, as you can see, it is shaped like a triangle and it's a pyramid. So if I was going to say that something was a square pyramid, it would have a base of a square and it would be in the shape of a pyramid. A triagonal pyramid has a base of a triangle and it is shaped like a pyramid, which means that it's upwards. This is why it's called trigonal pyramidal, because its base is a triangle, but it has a 3D structure, which makes it look more like a pyramid than a planar triangle, right? And all of this is caused because there's a lone pair up here, which is repelling each one of these away from it. All right, so now that's trigonal pyramidal. It is like tetrahedral, except it's not, because we don't consider the lone pairs when we are looking at their molecular geometry. So in this picture, the lone pair, it's as if it's not even there, but it is extremely important when it comes to determining the 3D shape of the molecule. All right, so let's move on to another one. By the way, this is AB3E because there's only one lone pair and there are 3 surrounding molecules. Now, the next molecule we're going to be looking at has 2 lone pairs. So when I look over here, I can see that I have one central molecule, one central atom, 2 surrounding atoms, and 2 lone pairs. So if I look at a water molecule, this is my A, the one central molecule. These are my B's, and these are my E's, my 2 lone pairs, okay? Now, when I look at this molecule as well, it also takes on an almost tetrahedral conformation because it has 4 components, 1, 2, 3, and 4. So its bond angles repelling each other are approximately 109.5. Again, we'll talk about this slight variation in a minute. But basically, because they are all also taking on this tetrahedral conformation. But because, of course, we don't consider these, this is called a bent molecule. So say we have our 2 lone pairs here and here. These are each repelling these away, and that is why water has this bent structure, right? This is extremely important. The properties of water actually depends on this bend and these lone pairs repelling the water away. You are not going to find water in this shape. If you do, it is not going to behave like water. All right, so let's go ahead and look at the 3D structure of that for a minute. All right, so let's look over here at the 3D structure of H2O. You guys can see here that there are 4 components surrounding it, and if I push this closer, it'll get closer. If I push it away, it'll get away, but in the end of the day, this is the conformation that it wants. This is the structure. It's very close to this guy right here, where everything is also kind of in the same positions, but it's not exactly the same because we are talking about lone pairs here, not 2 other atoms in these positions, right? All right, and now the last thing we need to talk about is why were the bond angles of ammonium and oxygen slightly less? So the bond angle of ammonium, these do not, even though technically there are 4 components, so they behave kind of like tetrahedral geometry, where everything is basically in the same position as a tetrahedron, but they're not. And that's because lone pairs have a stronger force of repulsion than the other atoms. So when these guys are repelling each other, they are not repelling each other as strongly as this one is pushing them down. So as this one basically tries to squeeze them closer to each other, because these lone pairs want more space for themselves. And that's why this does not end up being 109.5, but it ends up being slightly less. And here, we have two lone pairs. So together, their force is combining to push these two even closer to each other so that these two can be as far apart as possible. And that's why the bond angle of water is slightly less than the bond angle of ammonia, because the lone pairs are pushing these hydrogens closer to each other even when they try to repel each other and stay at 109.5, which is where they would rather be. They can't, because the lone pairs have a stronger force of repulsion than the atoms have. All right, guys, good job. You can go ahead and try the quiz for day